Hello guys, welcome to my channel. My name is Akinlolo Akinsanya and this is my chemistry class. If you're new to this channel, don't forget to subscribe, like and share, and also click the bell button so you can receive notification whenever I drop a new video. So in my last class, we talked about working with exponents. How do you add, subtract, multiply, and divide exponents? So that's what we talked about, and we need this. We need you to understand this because chemists use a lot of large and small numbers when they're working, and um, these numbers, when you know how to manipulate and work with these numbers, it makes life a lot easy. You are able to get the correct answer. If you don't do that, you will end up with wrong information. There was a time where the wrong conversion was used for a particular space project, and the what happened was very disastrous. I think it was back in the 1940s, there something like that. That there was no the conversion was wrong, and because of that, the jet or the spacecraft that they were building exploded. So it is very, very important that you know how to work with these numbers. As a chemist, one of the things that you're going to be doing a lot is observation, and they will teach you this in school, first year college. That a chemist studies matter and how matters uh, interact with other matter and what happens after that interaction takes place. So, as a chemist, you observe matter, and when you observe matter, you have to let us know what you observe. So, in this class, we're going to be learning the things that chemists do, okay? And this is going to be the precursor into learning about elements, molecules, and compounds, okay? So this is going to be the precursor to that. So as a chemist, we work with certain principles. First, we do observation. Secondly, after we finish all our observation, the next thing we do is representation. And then the third thing after representation is interpretation. So it looks like this. I'm going to draw a block that says observation. And then it goes this way. And you have another block that says representation. And then you have another one that says, I'm going to draw another block here that says interpretation. And then you come back again here and observe some more. So that is how we chemists behave. We observe. In this observation stage, you can be using different equipment. You can use a microscope. You can just use your normal eyes, just looking at what is going on. In that observation, you actually observing, you looking into the process to see what is going on, or an event. For example, you step out of your house and then you see people talking, a large group of people talking. Then you observe. You just watching them. That's observation. As a chemist, you might see rain falling, and you look outside your window, see how the rain falling, and you can say, "Oh my God, this rain is falling with a lot of wind." That's an observation, right? Use your regular eye. So in this observation stage, you might or may not use an equipment. Equipment may be involved. So use an equipment, or you can use just your eyes, your nose, your ears. So you can use any of these during the observation period, right? Then When it gets to representation is collecting data. So you're collecting data here, collecting and organizing data. That's what you're doing, organizing data. So that's what the representation part is. You're collecting data, you're organizing that data. So let me go back to my first example. You step outside and you see a large group of people talking. That's observation. You observe it with your eyes. Then you can start collecting data. How? Instead of just saying large group of people, you can say there are 50 people outside talking, and some of them are males, some are women. And you can say 50% of them are men, and then you can say the other 50% are women. That's representation. You're collecting data. Okay? You just didn't observe, your brain collected that data. You can see. And then that's what we do in representation. Then interpretation, there's a point where you've collected all your data and then you're not trying to explain that data. So you're collecting your data, here you're trying to explain data. Explain the data. Okay? So in the first step, you're observing with your eyes. You're saying that there are 50 for let's do an exercise. Say observation. Observed 50 people shouting. Okay? You observe it with your eyes. You saw it. Then representation. You said 50% are women and 50% are men. That's you're collecting data. Okay? And then in your interpretation, you explain the data. Now you're saying, okay, these 50% women were quiet looking, and these 50% men were actually the one shouting. So now you're interpreting the data that you got. So that's how chemists work. That's how it works. And when you interpret data, you're trying to explain that data that you collect, trying to explain what's going on. That's why you interpret them. And in explaining the data, you might make up a kind of a law, a theory, or even an hypothesis, right? You can develop that. So what are laws? What is a law, for example? When I say law, a law, are always true under the same condition. So for example, a law, I'm going to write it down just in case you want to write that. Laws are always true, okay, under the same condition. So that is, you interpret your data, you're trying to explain the data that you have, and then with that data, you can make laws, you can make theories, you can make hypotheses. So your laws are always true under the same condition. So examples of laws, for example, e.g., force is equal to mass times acceleration. Okay, F is equal to force and M is mass. So I can write this as force is equal to mass times acceleration. So why is this a law? It's a law because it's always true under the same condition. What is that condition? Here on Earth. If you have a big stone, okay, and you throw it very fast, it's going to have a force, and that force is going to can be measured. If you have a small stone and you throw it very fast, the force of the big stone with the fast acceleration is going to be greater than the force of the small stone with the same acceleration. it is always going to be true. If it's always going to be true under that same condition, then it is a law. Okay? So for example, F is equal to MA. Let's say the first mass of stone was 5 kilograms. Okay? And then you have the acceleration at that point was 600 meter per second squared. That's the acceleration. Okay? If you multiply this, you're going to have 3,000 Newton. Okay? But for the second stone, let's say it weighed 2 kilograms and it went through the same speed, 600 meter per second squared. If you multiply this, you're going to get 1,200 Newton. So you will see that the force here is much greater than the force here. You can try that out in all the scenario. In the US, you can go to Nigeria, try it out. You can go to China and try it out. Anywhere either you try this under the same condition, this equation is going to be true, and that is why it's called a law. Okay, so that is a law. But what is a theory? A theory is a principle that explains a body of facts. Okay, it's just a principle that explains a body of facts. Okay, and those laws that are based on them, that is a theory. It explains something. So for example, you have the Big Bang theory. Most physicists says there was a strong explosion in the cosmos, and that explosion gave rise to our planet and every other living thing on the planet. That is a theory. Okay, it's not a law. You're not going to hear a law of Big Bang theory. It's going to be a theory. The Big Bang, of course, even in this name, it has theory. Big Bang theory. Okay, theory sometimes are difficult to disprove, because when those theory are postulated, right, it might be that we don't have enough information to break that theory, so they remain for a long time. An example of theory at the time was atomic theory. Okay, that's an example of theory. Let me clean the board and then explain that. So in atomic theory, like the name suggests, theory says that matter is composed of small indivisible atoms. Indivisible atoms. So that was a theory, but that theory is no longer a theory, because we now know that atoms can be divided into even smaller particles, because now you have electrons, you now have protons, then you have neutrons, and then even here you can actually go further down to other particles. We're going to get there when we get there. I don't want to rush too far forward, but we're going to get there, and with the help of nuclear chemistry, you can break down even a proton to even smaller particle. So we know that that theory has been disproved. Thank God for newer kind of equipments that we have that can allow you to do that. But for so long, for the longest of time, this theory remained true. Okay, before we have the capability to even split the atom into even smaller elements. So that is a theory. So chemists work with different kind of matter, and this matter can be classified into different types. Okay, so we've talked about what makes up what a chemist do, and we've just talked about how they do what they do. So now we're talking about classification of matter. Matter is composed of small individual atoms. But what is matter? So what are the types of matter? So Now I'm going to discuss types of matter. Because you see, once you understand types of matter, it makes it easy to understand other things. So we have different types of matter. Number one, we have substance. Okay? We have substance. And substance are a form of matter that has a definite composition and distinct properties. Substance are a kind of matter that has distinct properties, and composition. So an example of that, what is an example of a substance that you know that has a distinct composition and properties? An example is water. The water here is the same water in anywhere in the world. Pure water is the same thing. It has 2 hydrogen, 1 oxygen. The way it looks is the same. If it's the gaseous way, it's gaseous. If it's the what's it called? Liquid way, it looks the same anywhere in the world. So that is water. So it's a substance. Water is a substance. It looks the same anywhere in the world. It has distinct properties, and you can always tell it when you go anywhere in the world and you have water. And now on the table sugar. Sugar has the same property, right? Table sugar has the same property anywhere in the world. Table sugar, that's an example of a substance. It's white, granular, the same thing. Anywhere you go, whether you're in the US, whether you're in the Caribbean, whether you're in Africa, anywhere, sugar has distinct properties and composition. Composition means here that when you look at the chemical formula, it's always the same every time, and it always tastes sweet. So that is sugar. So that's one type of matter. Another type of matter that we have is a mixture. Okay, a mixture. And you know this because a mixture is the combination of different substance, different types of matter. So, for example, you have water, and you have, say, stone. That is a mixture. Stone and water. That's a mixture, right? So, but that's a different kind of mixture. We have 2 types of mixture. We have the homogeneous mixture. And then we have the heterogeneous mixture. So we have 2 types of mixture, homogeneous and heterogeneous mixture. What is homogeneous mixture? Well, in homogeneous mixture, the mixture is the same throughout. So you have just one. There's no boundary. There's no boundary. So we don't. A mixture contains 2 different substances. So mixture contains 2 or more substances physically combined. That's the mixture. 2 or more substances physically combined. And the mixture can either be homogeneous or heterogeneous. If it's homogeneous, okay, what that means is that the mixture has substances that are combined and have no boundary. So you can see, for example, I'm going to clean this up. For example, you have water plus salt. And when I define mixture, say two or more substances that are physically combined, okay? Physically combined means there's no chemical reaction in there. You just combine them. So you have water and salt. When you put your water and your salt, and then you mix it, you're gonna have a cup of water with salt. But all you're gonna see is just water. You won't see the salt. When you mix it very well, you won't see the salt. The same thing with water and sugar. When you put sugar in your tea, okay, you put sugar in your tea and you mix it, you can't tell the boundary between the sugar and the tea, or the boundary between your water and your sugar. You can't tell. It just looks like one plain thing. Unless you drink it, then you will know. Say, oh my goodness, this water is salty, or this water is sweet. That's when you would know that there's sugar in the water. But if you don't taste it, you would not know. So that is a homogeneous mixture, because it's just one single mixture. There's no boundary between them. Then you have heterogeneous mixture. In heterogeneous mixture, there's a boundary. You can tell where the first mixture started and ended, and when the second mixture started and ended. You can tell. It's not just single. An example which you already know is water plus oil, right? Water plus oil. If you put oil in water, you have a cup of water. You put the water in here, and then you pour oil on top of it. The oil is going to be here. And you can tell that there's a boundary. You can tell that the water started from here and it ended here. You can tell that boundary is always there. And then you can tell when the oil was poured in and when it stopped. Why? Because they did not mix. It's a mixture, but it's not fully mixed in, right? It's still separate. So that is an heterogeneous mixture. Another one is you have sand, and say you have iron fillings. For example, that's an example of a mixture. Really, because you can see the iron, you can see the sand, because they will not mix completely, right? So you can see it, and you can easily separate them. You can separate them by using a magnet, because sand is not going to get attached to a magnet. And the reason why that is possible is because a mixture is physically combined. So you can easily separate them because they are physically combined. So when I pick up, if I have a sand here and I have some iron fillings here, I can get a magnet and take off all the iron fillings and the sand will remain. In this case, I can punch a hole here and all the water is going to come out first, and when the water is completely out, I can close this hole and the oil will remain. So I can easily separate it. So that's the difference between heterogeneous mixture and homogeneous mixture. I hope you've enjoyed this class. If you're new to this channel, don't forget to subscribe. Also, don't forget to like, share, and also click the bell button so you can get new notification when I drop a new video. In our next class, I'm going to be teaching, we'll now start on molecule, elements, molecule, compounds, chemical equation, chemical compounds that are combined chemically. We're going to talk about that. We'll start working our way into chemistry little by little. And I'll give you real life examples, something you can see on a daily basis, to help you understand these terms. So I'm grateful that you watched this video. When you comment and like, it lets me know that you actually like this video, that what I'm saying makes sense, that you're understanding what I'm saying. So it makes me happy and it makes me want to do more. So please don't forget to like and comment on this video if you have any comment. At least just boost. If you don't have anything serious, just boost my ego. Tell me I'm doing a good job and you like the video. Again, thank you guys for watching this video. I appreciate it, and have a wonderful day. Bye-bye.